Many students shy away from the ACT because of the science portion. But with the changes coming to the SAT, shifting gears and focusing on the ACT might just be the winning move for you. Join me in this video where I'll show you how you can ace the ACT Science. But before we do that, let's clarify what the ACT is not about. ACT Science is not about your science knowledge. Instead, it's about how quickly you can read and understand scientific passages. With that being said, we'll be getting into the scientist mindset and tapping into strategies that scientists use every day to quickly learn about and understand new scientific articles. Hi, I'm Zainab, aka the STEM Coach. Having studied at Caltech, University of Michigan Ann Arbor, UCLA, and the Johns Hopkins University, I'm probably one of the biggest school nerds you'll meet. I coach students to reach their academic dreams, and I created this channel to help you as well. Let's first orient ourselves. ACT Science has 6 passages and 40 questions, for which you'll be given 35 minutes to complete. Of those 6 passages, 5 of them will have charts, graphs, or tables. And the techniques that we'll be covering in this video apply to those 5 passages. Now, scientists speed read through such passages all the time. They know what key elements to look for so that they can quickly grasp the gist of an article in a short amount of time. Let's look at an example together and then see how we can apply the same techniques to ace the ACT Science. Scientific articles come in different templates, but they all share certain sections. For example, there's the introduction, where here we'll get a background of the field and a quick introduction to the method or algorithm or experiment that's being presented. And then there's the methodology section where we get into more detail of what the algorithm or experimentation is about. Here you might find equations, tables, and graphs. And ultimately, most papers end with a results section and then a discussion section talking about limitations and future work. And then there's most definitely a conclusion. So you can imagine how overwhelming it can get if you're going to have to read through all of this information and try to understand it in a lot of detail, especially that there are so many manuscripts that come out all the time and you want to try to stay on top of things as a scientist. So frankly, I was very overwhelmed at the beginning of my PhD studies until a mentor shared with me her strategy to quickly read through manuscripts, which is what I call the scientist's way of speed reading. What she said was start by looking at the introduction. So read the introduction. So let's see here. We'll just read the first sentence for the interest of time. Okay, this is about conductivity of aluminum and copper. She said then skip through all the rest of the details, don't worry about it, and then just land on the conclusion section. Read the conclusion so that you understand what story is being told. So here, for example, copper, we say, oh, it has remarkable conductivity. And then in the second paragraph, we're talking about aluminum, and aluminum has better weight, so it weighs less and therefore it's cost effective. Okay, so now we get the gist of what this manuscript is about. So then she said, go back the beginning and now start looking at all the tables and the graphs. So for example, here, table 1, okay, this is just an introduction where we're looking at the properties of these two material. And then the next figure here, well, let's see what this figure is presenting. What story is this figure giving us? The y-axis is the conductivity, the x-axis is temperature. Okay, so it's showing us how conductivity varies as temperature increases. And we got to look at the legend to see which one's which. Aluminum is the dotted one, which makes sense. It's the one that has lower conductivity. Now, at this point, you've gone through the article once and you understand what the article is about, and you can decide whether you want to move on to the next article or if you want to go back and learn more about this research in more detail. Now, let's tie this back to ACT Science. Let's look at how we can apply the scientist's speed reading technique to the ACT Science passages. Just like scientists would quickly look through the introduction of an article, start by skimming through the first sentence or at maximum the first 2 sentences of a passage. This is just to give you an idea of what the passage is about. Is it an astronomy passage, or is it perhaps a chemistry experiment? Next, jump to the questions. The questions are like the conclusion of an article. They'll give you a roadmap to the answer. Now, for each question, follow the clues by looking for what I like to call the 3 W's. The where, so where to look at. Is it the question about passage 1, or should you be looking at graph 2 or chart 1? The who, so who should you be looking for? Is it element X, or perhaps the speed of an object, or the time for an experiment to complete? And lastly, the why. Are we looking for a trend like increase or decrease of a value? Or are we looking for the exact value at a specific row of a table or at a specific point of a graph? Let's look at a few examples together. We're going to look at a couple of questions from an ACT Science practice test that's linked in the description below. We won't be solving these questions, but we will be dissecting them, in that we'll look at the where, the who, and the why. So let's look for those in this question. Well, table 1, that would be the where. The who would be at temperature 298, the density of nickel. So that's what we're looking for. And the why. Well, the why for here is that we're looking for an element that has a value close to that of nickel's density. Let's look at a different type of question. For this question, well, we're given to look at experiment 2. And we're being asked about volume of hydrogen gas at 325. So that's our who. And then the why would be, well, look at the answers. It's just a value. They're asking us to find the value corresponding to the volume of that hydrogen gas at that certain temperature. Let's look at one last question. For this question, the where is figure 2. The who would be the greatest variation of pH level of NaOH. And the why, are we looking for the greatest variation in pH level? What is the question asking us to find once you're located where and who to look at? Oh, for this question, we're asked to find the volume that corresponds to our who that we found. So we want to find the volume corresponding to the greatest variation in pH level. So remember, skim through the first 2 sentences, skip to the questions, and look for the 3 W's, the where, the who, and the why. Now, let's get into our scientist codes or mindsets, and join me in the next video where I'll be walking you through an ACT Science test.